What I'm going to talk about here is give a real quick review of some projects that CDCB is involved with other collaborators, just to kind of let you know what we're working on that you might hear more about down the road, right? And then I'm also going to talk about what are traits that might be interesting in the future, and I'm going to talk a little bit about the process for bringing new traits into the world. And I don't know if I have time for any closing thoughts, but here in the photo you'll see that's some of the folks from the CDCB team, along with the land-grant university dairy cattle genetics researchers in a meeting we had in Minnesota last year, just to emphasize that in addition to the close collaborations we have with USDA Agile, with National DHIA and their partners, we're also involved in working closely with the universities. So where are we on some of our current projects? Many of you have heard in the past, Dr. Malia Caputo on our staff has given updates periodically on our lactation factors project. The goal of that project is to collect all milkings for animals so that we can update the factors we use to project lactations. The whole point of that is so that we can compare the performance of two animals, we compare them on an apples to apples basis. This involves working with herds all over the US, Holstein herds, Jersey herds, different regions, different sizes of herds. That project is ongoing, but it's moving along nicely. And one of the nice things that's coming out of that, in addition to data that we can use to update our correction factors, is information, milk spectral data, milk fatty acid data that we believe we can feed into some other projects that we can build into some new tools down the road. So that's going nicely. We're also involved with some projects that are supported by the Foundation for Food and Agricultural Research. So these are projects at some of the land-grant universities. So, one of them is focused, and I'll show a couple of slides after this. We're working closely with folks at University of Wisconsin, but also some of the other universities, to collect methane emissions information, to figure out the best way in the US population to predict those emissions, and figure out what to do with them to make tools, right? We're also doing some work that's related to, nutrient utilization and other emissions, and development of these methanogen inhibitors, right? Because there are bugs that live in the rumen of the cow. Some of those are responsible for making most of the methane that cows burp out. So the question is, can we manipulate the makeup of that population so that cows emit less methane while maintaining their levels of production and other performance? And so we're involved in all of these projects through funding. We're working closely with Francisco Peña-Garicano's team at University of Wisconsin. Dr. Peña-Garicano and his folks are here with us, and they're working on several different aspects of methane. So they're looking at developing evaluations, understanding things going on in the rumen, making nutritional modifications to diets to limit methane production. So it's really a full spectrum approach, and it's also collecting other information about the animals, right? So fecal microbiome, oral microbiome, rumen microbiome. And this project is going well. There are about 3,000 animals that have been phenotyped. I know that may not sound like a lot when we talk about the tens of millions of animals that go into some of the other evaluations, but you have to start somewhere, and we have to remember that it's expensive and requires special equipment to record the methane evaluations. So we have to start somewhere. And as I said, they're also collecting milk spectral data. Our friends in Canada have suggested that you can use the mid-infrared spectral emission data from milk samples, from testing milk samples, to make predictions of methane output. And they're also sampling the microbiome. And this again is also labor intensive, and we're still trying to figure out the best way to use that information. We are working internally. You already heard mentioned earlier, single-step genomic evaluations. Currently, we do the genomic evaluations in 2 steps. First, we use the pedigree and performance information to estimate breeding values, and then we add in genomic information afterwards. This has worked well for us, but it is a little bit clumsy to have it in 2 pieces, and there are some statistical advantages to going to a single-step model. We can avoid some potential sources of bias, and frankly, it is a much easier system for our operations team to work with. There are fewer points of failure. It's easier to figure out where there are problems when there are problems. And this is a big project. A lot of progress has been made. Things like unknown parent groups and meta-founders. That's maybe not so interesting. We found some ways to improve the way that reliabilities are predicted for animals that are important. We've done work with the folks at University of Georgia and at Holstein Association USDA to prove that it's feasible to do an all-breed single-step evaluation so we can continue doing what we're doing. And then the software development team has been working with the IT team to move. Currently, all of our calculations are done on kind of one big box, right? It's a little bit of an old-fashioned model. And the problem is that simply doesn't scale up to the computing we have to do with single step. And not only have Chip Donatone and Nathan Blair and those folks move things to the cloud, they've also made substantial speed ups in the calculation time. And that benefits everybody because we can get things out the door faster. If we find a mistake and have to fix it, it's feasible to redo the calculations, so it ensures we can get the highest quality evaluations out the door. We're also working on some other projects with the folks at University of Georgia. One, we work closely with them on single step because they invented single step, and we're going to be using their software. We're also doing some other things, right? They did some really cool math tricks to make a certain approximation that's used go really fast. I hope none of you ask me what the math trick is because I don't know what an elliptical integral is. I asked my kid to figure it out. He's majoring in math. He said he'll get back to me. We're also doing some work on different ways to estimate genetic diversity, right? We understand the continued concern about changes in genetic diversity in our populations, and then also some things like genome-wide association studies. What you need to know about that is when we come to you and tell you, hey, we found some genes that are associated with a trait, genome-wide association studies are the methodology we use to associate a gene or a region of the genome with a phenotype. We're also doing some work with Breno Fragamini's group at University of Connecticut related to genotype by environment and heat stress work. And they've recently been doing some work using herds in the state of Texas, right, that experience a lot of heat stress for a long time, and herds in the state of Wisconsin where they don't typically experience a lot of heat stress. And they've shown some interesting differences. And one of the things that's interesting is if you account for the genotype by environment in the model, it helps the predictions for the animals in Texas. And it doesn't really have any impact on the animals from Wisconsin because the animals from Wisconsin didn't experience heat stress anyway. So we're continuing to work with Breno and his students on this. I'm going to talk a little bit here about which traits may be of interest in the future and a little bit about how we go from an idea to an evaluation. And I'm not going to spend a lot of time on this slide. This whole topic of the cow of the future has received a lot of attention in the last few years, and you certainly can't go to a dairy science meeting without there being a talk about the cow of the future. And there's maybe some very broad consensus, but I'm sure for everything I've listed here, someone will come up to me after the meeting and say, John, that's a terrible idea. Some of you are probably texting me even as I speak to tell me that this is a bad idea. The point is to get people talking and thinking. And we absolutely base the work we do with new traits on input from the field. So we work with groups like the CDCB Board of Directors because all 4 sectors of the industry are represented there. We have the Producer Advisory Committee. So we sit down in a room with dairy producers and hear from your own mouth what it is you need, and it's not mediated through other people's opinions. We also meet and interact with other groups from allied industry because you guys know as well as I do there's a lot of steps between my chair in front of my desk and the cows in your barn. So we need that input, right? Because just because a scientist has an idea about something that's useful doesn't mean it's actually useful to you. And we really want to align the things that we're doing at CDCB with the things that are needed by the dairy industry. And I'm just going to run through this real fast because I talked about this for like an hour yesterday at University of Wisconsin. I don't have an hour today. So this is the real broad strokes. How do we go from an idea to a new trait? So we start with the red arrow on the far left. That's someone's like, hey, I wonder if we could measure this. You know, okay, maybe you write a proposal, maybe you go to your experiment station director, whatever, we go to National DHIA and find some data. And then we move to the dark blue bar where we're actually doing research, right? So we're calculating variance components, we're just looking at the raw data. How are they distributed? What are their properties? What's the relationship of this trait to other traits, right? And Taylor talked a lot about some of those things in her talk. If this looks really promising and our consultation with the PAC and other groups says, hey, no, this is something that could be useful, we move into pre-production. And that's things like, you know, the development. Taylor talked about our extract programs, for example, that reach into the database, pull the information out and get it ready. If we're working with Agile USDA on something, they often develop programs that they then hand to CDCB. Right. And then we move into sort of our testing and validation phase, and that's where we give it to Dr. Ezekiel Nicolazzi and his operations team. And those folks are really mean because they look at stuff and they ask, you guys ask tough questions. Those guys ask even tougher questions. And the point is they're kicking the tires to make sure that this thing is actually ready to go out the door, that all of the answers make sense. Right, that everything is ready. And then when they're convinced that the programs all work, the results make sense, you know, then we would move into production. And so when we move into production, test files go out to industry collaborators, right? So we have, you know, folks like Ryan Starkenberg and Bob Welper and other colleagues who scrutinize everything, and they're the guys who are like, this number changed by 0.2 between May and June. What's going on with that? We do our education and outreach efforts to explain what these new traits are. Then you'll see the PTAs in the files, and then you have a new tool in front of you to use. And this is a process that does take time because we have to go through a lot of steps. The goal is to put something in front of you that's useful and trustworthy. It's not to put something in front of you as fast as we possibly can. And you know, I already addressed some of these points, but you know, how do we decide what we're going to do next? And as I said, we often figure that out by talking to people. We look at what's technologically possible or what data are available in the system, right? We look at what their properties are. The existence of data flows is important because if we have to start from scratch with building a data collection system, that takes a long time, and it's not just about the amount of time it takes at CDCB. It's about the time it takes, you know, at the milk testing labs if we ask them to change things, at the DRPCs, you know, on the farm if we're asking you to put new things into Dairy Comp or into DART that you're not used to putting in there. So, you know, we try to think about all of that. And then we also think about the technical characteristics of traits. Is it heritable, right? That seems like a really basic question, but you know, sometimes we start with the basic questions because if the heritability is 0, maybe we can produce a tool that's useful, but it won't be a genetic tool. And then is CDCB the best group to offer that tool or somebody else? So for closing thoughts, right, and I know we've all said this morning about how important collaboration is, but it's absolutely true. The system that we've all built in the US, right, since Herman Rabild started the first DHI in Michigan in like 1894 or so, right? We've built this system through collaboration with National DHIA. We've built this system through collaboration with dairy farmers, with the genetics industry. As we've moved into genomics, we've built collaboration with genotyping laboratories and genomic nominators. And so the idea of collaboration is built into everything we do at CDCB because it works. Obviously, our historical collaboration with USDA, where USDA scientists built the system that we're using today. And that is going to continue in the future, the partnership with all of the dairy producers in the room and listening online. We develop new traits, the CDCB staff, based on what the industry tells us they need. Yes, we do also collaborate with university folks, and sometimes they're pursuing things that are maybe a little more blue sky, a little bit more longer term, but that's okay because, you know, they're looking down the road and maybe what they're working on leads to something in the future that works for all of us. And, you know, I just wanna, you know, I always wanna argue for the continued cooperation. Sometimes there's friction because different groups have different objectives. That's okay. One of the things I love is that folks in this room aren't afraid to call me, text me, email me, and tell me, hey, I enjoyed your talk, but I think you're dead wrong about this thing you said. That's okay. If all we ever do is agree with each other, then we're blind to challenges that we need to be aware of. We're missing somebody's point of view. And so, you know, let's all keep working together as we have so successfully for the dairy producer. And I'm happy to answer any questions related to new traits where we're going in the future.
Okay, we're going to take a few minutes for just a couple questions because, John, I have been sitting on this one since this morning.
Okay.
With so many female genotypes coming in from abroad, should new traits be chosen and developed keeping international producers in mind?
Well, I think that I'll admit that that's a question I haven't thought a lot about, but maybe to the person who posed the question, I might need an example, because when I look at the portfolio of traits that CDCB offers, right, I see us really growing to cover health, longevity, fertility, mobility, and when I look, say, at what are in the selection goals of other countries, I see a lot of similarity. So it's certainly possible that there's something that's really important in another country that we're missing, but I think in a general sense we're broadly aligned with what folks are doing in other places. So I know that's not a super specific answer. Maybe you could help me with a little more specific example of something where you feel like we're missing out on something important.
Sure. Quickly, if you have the answer, what changes in heritability do you foresee in, what changes in heritability do you foresee with the switch to single step?
Okay, heritability, okay, and Taylor did a nice job of talking about it. Heritability is a characteristic of a population. So I don't anticipate to see heritabilities change very much. And if they do, that means that we've been doing a poor job of estimating them under our existing models. When we estimate variance components, that's a fancy way of saying the pieces that go into heritability. When we estimate variance components with our traditional model and then compare them to variance components estimated with single step, the changes are very small. So you're not going to see the heritability of something go from 4% to 12%, right? We have no reason to believe the changes will be notable.